Ionic formulas. Formula units. A chemical formula shows the kinds and number of atoms in the smallest representative unit of a substance. A formula unit is the lowest whole number ratio of ions in an ionic compound. Every ionic compound has a 3D array of positive and negative ions. Predicting an ionic formula. By examining the electronegativities of two elements, it can be determined if they will form an ionic compound. Then, if they will form an ionic compound, its formula can be predicted by examining the atom's valence electrons. Let's use potassium and oxygen as an example. We'll use the electronegativity table on the next slide to answer the first question. Example 1, potassium and oxygen. Potassium's electronegativity is 0.8. and oxygen's is 3.5. The difference of 2.7 is well more than 1.7, so these atoms will form an ionic compound. Now let's find its formula. The answers to these questions will determine the formula. How many additional valence electrons does oxygen need? How many valence electrons does potassium have to offer? How many potassium atoms will it take to give oxygen the electrons it needs? The answers are on the next page. The answer to the question, how many additional valence electrons does oxygen need, is 2. How many valence electrons does potassium have to offer? 1. How many potassium atoms will it take to give oxygen the electrons it needs? The answer is 2. So we will need 2 potassium atoms for each oxygen atom. The formula is written with the metal first, so the formula unit for the ionic compound formed by potassium and oxygen is K2O. It's shown in this diagram with the potassium, 2 potassium atoms, with each having a valence electron, contributing that valence electron to the oxygen atom, so the oxygen atom now has 8, a full outer shell. Note that oxygen captures the electron. It is not shared with potassium. Potassium is nearby due to its electrical attraction to oxygen, now that they have opposite charges. Example 2, magnesium and nitrogen. Will magnesium and nitrogen form an ionic compound? If so, what will its formula be? Try it first on your own before looking at the answers on the following slides. Magnesium's electronegativity is 1.2 and nitrogen's is 3.0. That difference of 1.8 is more than 1.7, so they will form an ionic compound. Now let's find its formula. Once again, these are the key questions. How many additional valence electrons does nitrogen need? How many valence electrons does magnesium have to offer? How many magnesium atoms will it take to give nitrogen the electrons it needs? The answers are on the next page. How many additional valence electrons does nitrogen need? It starts with 5 valence electrons. To reach 8, it needs 3 more. How many valence electrons does magnesium have to offer? It has 2 valence electrons. How many magnesium atoms will it take to give nitrogen the electrons it needs? 1.5. But since atoms are indivisible, we need to find the lowest ratio of whole numbers to give us 1.5 magnesium atoms for every nitrogen. The answer, 3 magnesium atoms for every 2 nitrogen atoms. The formula unit for the ionic compound formed by magnesium and nitrogen is Mg3N2. And that's shown graphically here, where you see the 3 magnesium atoms with their 2 valence electrons each, and you see 2 nitrogens with places to put 3 valence electrons. By taking these and combining them, you can fill all the gaps. Nitrogen has a complete shell of 8 valence electrons. Magnesium is now attracted to the nitrogen because it has a positive charge, while nitrogen, due to these excess electrons, has a negative charge. So these electrons are captured by nitrogen, but it leads to the attraction between magnesium and nitrogen to form the ionic bond and the ionic compound. Here's an alternative method to finding the formula once you know the ionic charges. Write down the ions side by side along with their charges, always writing the metal first. So here we've written magnesium and then nitrogen, and we put the charge for magnesium 2 plus and the charge for nitrogen 3 minus. Now crisscross the numerical values of the charges. Don't keep the plus and the minus, but just take the 2, which is the superscript for magnesium, make it the subscript for nitrogen, as here. Same thing, take the 3 minus for nitrogen, take the 3, make it the subscript for magnesium. And we're done. We have the formula, magnesium 3, nitrogen 2. If we had done this, and these numbers, instead of being 3 and 2, were 6 and 4, for instance, we would then have to reduce them to lowest terms. We don't have to do that because these are already in lowest terms. For our third example, we'll write the formula for the ionic compound formed by calcium and sulfur. We'll use the alternative method. We'll write down the ions side by side along with their charge, always writing the metal first. So calcium, it's a group 2 metal, so it has a charge of 2 plus, and sulfur is a group 6 non-metal, it has a charge of -2. We then crisscross the values, so we take the 2 from sulfur's superscript and make it the subscript for calcium. We take the 2 from the superscript of calcium and make it the subscript of sulfur. In this case, these aren't lowest terms. We can divide both of these by 2, so the formula is calcium sulfur, or CaS. We don't keep the 2's because this represents the ratio of calcium to sulfur atoms in the ionic solid. Naming binary ionic compounds. The formula for a binary ionic compound begins with the cation, the metal, and is followed by the anion, the nonmetal. For example, CaS is the ionic formula formed by calcium and sulfur. The metal symbol comes first. Similarly, the name of an ionic compound starts with the name of the cation, the metal, followed by the name of the anion, the nonmetal. The name of the cation is usually the same as that of the neutral atom, but the name of the anion is slightly different than that of its neutral atom. Names of cations. Many cations, including all of these, have the same name as their original neutral atom. Hydrogen, lithium, potassium, cesium, silver, magnesium, calcium, barium, cadmium, aluminum. There's no difference between these cation names and the names of the original neutral atom. Naming anions. The names of monatomic anions are almost the same as that of their original neutral atom, but end in IDE, or IDE. For instance, nitrogen becomes nitride, phosphorus becomes phosphide, oxygen becomes oxide, sulfur becomes sulfide, fluorine becomes fluoride, chlorine becomes chloride, bromine becomes bromide, and iodine becomes iodide. Naming binary ionic compounds. Binary, which means 2-element, compounds are named by writing the name of the cation followed by the name of the anion. The name of the cation is the same as the metal name. The name of the anion is the same as the nonmetal, with the suffix changed to IDE. Binary ionic compounds all end in -ide. Examples: sodium chloride, potassium iodide, lithium sulfide.